talk a lot about engineer shortages, but the actual story is much weirder than that. The shortage is real in some fields, fake in others, and inverted entirely in China. Let me walk through the math that separates fact from narrative. Start with petroleum engineering. In 2024, there were about 19,600 petroleum engineers in the US workforce. BLS projects, 1,200 job openings per year over the next decade. Divide the stock by 30-year careers, and you get 653 engineers per year needed to hold steady. That's roughly balanced with the 100 pounds bachelor's degrees awarded in petroleum engineering annually. Sounds tight, right? Except it's not. The wage signal, 141k median, tells you the tightness is real. Compare that to chemical engineering. About 21,600 chemical engineers, but 12,000 bachelor's degrees awarded annually. That's an 11-to-1 ratio of grads to jobs. Yet chemical engineers don't earn less than petroleum engineers. They earn less because they're not all working as chemical engineers. Most end up in pharmaceuticals, semiconductors, or oil and gas as process engineers. The degree is a proxy for systems thinking, not a specific job title. This matters because it tells you something about what the labor market actually prices. It's not scarcity of the degree, it's scarcity of people who can do a specific kind of work in a specific industry. Petroleum engineering is tight because the substitution is low. A mechanical engineer can't walk into a reservoir simulation role, but a chemical engineer can walk into a battery factory and design the electrolyte process within weeks. That's why Chemi is overproduced on paper, but still commands decent money. The degree opens doors to multiple industries where process engineering is valuable, now civil and mechanical. Civil engineering, about 369,000 jobs, 23,600 openings per year, about 21,000 degrees awarded annually. Mechanical, 293,000 jobs, 18,000 openings, 44,000 degrees awarded. Both look like oversupply at the headline, but civil has collapsed into the 95k wage range, and mechanical sits around 102k. Why the wage difference if both are oversupplied? Because the real estate bust in the last decade destroyed demand for civil engineers in property development. That was the dominant employer. Mechanical engineers disperse across automotive, aerospace, manufacturing, HVAC, robotics, dozens of industries. One industry implodes, civil engineers suffer. Mechanical engineers find work elsewhere. Electrical engineering is the outlier. 288,000 jobs, 17,500 openings, 28,000 degrees awarded. That's roughly balanced, but electrical also grows at 7%, faster than almost any other field. The reason is electrification. Data centers need electrical infrastructure. EVs need power electronics. Grid modernization needs controls and renewable integration. The openings exceed the supply of dedicated electrical engineers, but the substitution into software and computer engineering is huge. So you see mechanically trained people designing power systems, physicists building battery management algorithms. The wage holds steady at 111k because there's genuine downstream demand, not artificial scarcity. Which brings us to chemical engineering, the weird outlier. It has by far the worst per capita job market, roughly 1,200 openings versus 12,000 grads annually. Yet chemical engineering is disproportionately represented among Fortune 500 CEOs. Per capita, about 3 to 4 times overrepresented. Why? 3 confounders. First, the Fortune 500 is structurally a chemical process industry index. You have super majors, refiners, pharma, CPG with heavy process R&D. Second, chemical engineering is the most academically selective engineering major. Higher SAT, higher GPA. Selection effect. Third, the schools producing chemies, MIT, Berkeley, Georgia Tech, have strong corporate recruiting pipelines. School signaling does real work, but the CEO data is a selection effect, not evidence of broader labor market dominance. It shows that if you survive a chemi program at a top school and stay in the chemical process industries, your upside is extraordinary. It doesn't mean chemi is a better career bet than electrical or mechanical in the aggregate. What it does mean is that the degree trains you to think about systems, optimization, and operations at a level that translates to general management. Now China. The numbers are almost incomprehensible. In 2022, China awarded 1.6 million engineering bachelor's degrees. The US awarded 144,000. That's an 11-fold difference. Add in China's vocational engineering programs, maybe another 1.5 million per year, and you're at roughly 3 million engineering credentials issued annually in China versus 200,000 in the US. The labor market is completely unbalanced. China produces so many engineers that most don't work as engineers. Urban youth unemployment is 15 to 20%, and a huge fraction are overqualified engineering graduates. Civil engineering is in free fall. The real estate bust, Evergrande, Country Garden, destroyed the dominant employer. Civil engineers in Tier 2 and Tier 3 cities are taking 40% pay cuts. It's a genuine employment crisis. But the shortage is real in strategic frontier industries. Battery chemistry, solar, semiconductors, EV powertrains, advanced materials. These sectors are all hiring aggressively. Process engineering for new energy materials is undersupplied. This is why China can iterate battery chemistry and electrolyzer design at speeds Western firms can't match. They have 10x the engineering labor pool, most of it cheap, and they concentrate it in the fields that matter for energy transition and semiconductor regions. In the US, you're competing for limited process engineering roles in energy and infrastructure. The wage premium is real. Petroleum to energy transition roles are opening up. But the absolute supply of jobs is constrained. You're not oversupplied by the mass balance. You're in a genuinely tight field. In China, that same skill set would be in the top tier of process engineering demand. Batteries, electrolyzers, rare earth separations. But the wage would be maybe 40% of what you'd earn in the US, and the political risk is higher. The deeper takeaway: don't look at degree production to forecast your career. Look at where the people with your skill set are making money and doing the work that matters. That's petroleum and oil and gas process engineering for the last 15 years, and it's shifting into energy transition, battery, hydrogen, direct air capture, geothermal, grid-scale thermal. Those are the industries where the supply and demand of process engineering actually tightens. Everything else, chemical, civil, mechanical, electrical in low-skill applications, is either oversupplied or substitutable. China confirms this. They produce 10 times more engineers, but the money and impact concentrate in 5 or 6 frontier sectors. The rest is unemployment or wage suppression. You already know this intuitively from your own path. You're not valuable because you have a Chem E degree. You're valuable because you can design process plants that work at scale in hard geographies with tight economics. That skill is rare, and it will be rare for decades because it requires both technical depth and operational judgment. The mass balance is just the floor beneath it. All right, that's the engineering labor market breakdown. Petroleum, chemical, civil, mechanical, electrical, and how China's completely inverting the game. If you found this useful, hit that subscribe button. We break down the real numbers behind engineering careers, salary trajectories, and where the actual jobs are, not just the hype. Drop a like if the mass balance math made sense to you. And share this with anyone you know wrestling with the engineering degree decision, or trying to figure out whether their field is actually in shortage or just saturated with narrative. Check out our other videos on energy engineering, geothermal, direct lithium extraction, and what data center infrastructure looks like from an engineer's perspective. Links in the description. If you've got questions about your own engineering path or want us to break down a specific discipline, drop a comment below. We read them all. Thanks for watching. See you next time on Engineer Facts.